Hi, my name is Avery, and today I'm going to be teaching you about the scientific method as it applies to life science. Step 1 of the scientific method is to ask a question. To do that, you need to ask a testable question in science, something that you can experiment on to find your answer. Make sure that your topic is definitely something you're interested in learning more about. Step 2 is to do background research. You want to research your topic so you can understand more about it. Make sure you understand what your experiment is about and why you are even testing it in the first place. Step 3 is to construct a hypothesis. What is a hypothesis? Well, it's an estimated guess on what you think might happen in your experiment. When you're writing one, make sure to use an if-then statement, such as, if this, then that will happen. Step 4 is to test with an experiment. Repeat your test over and over on your given subject to make sure that you have a result. Your ending result may prove your hypothesis wrong. But that's okay. It just means that your experiment is further educating you in a more specific and scientific topic. Step 5 is to analyze your data and make observations. When experimenting, you want to make sure you're recording what happens. You can write it down, draw pictures, or even take pictures of what is happening. Analyze the details on what you're experimenting, such as color, shape, temperature, and weight. Step 6 is the conclusion, the final step of the scientific method. Your conclusion is a synopsis or summary on what your experiment was and why you tested it. When writing it, make sure to include what variables you might add or change next time to further expand your project. Now let's do a sample experiment. First, let's ask a question. Are a frog's internal systems the same as a human's internal systems? Let's find out. Let's do some background research on the internal systems of both a frog and a human. Humans are mammals and frogs are amphibians, making some of their respiratory or breathing systems a little bit different. They both also have the same major vital organs. Now that we know a little more about the anatomy of frogs and humans, we can construct a hypothesis. If a human were to dissect a frog, then you would see the same internal organs and systems as a human's. Great! Now that we have our main focus as to what we are looking for, the similarities between the insides of a frog and a human, we can conduct an experiment. What is a good experiment? Well, how about a dissection? If you follow instructions on how to dissect a frog correctly, you can see its insides for yourself. When dissecting the frog, make sure to observe and analyze what's happening. You can take some pictures of a human eye and a frog eye and place them next to each other for comparison. Or you might want to record your observations by writing them down in a small journal or notebook. Lastly, we have the final step, the conclusion. Our conclusion should determine whether or not our hypothesis was correct, why or why not it was correct, and further details on the experiment and research itself. Once you have finished that portion of the conclusion, move on to what you might do to further your experiment, and what steps you might take to make your project a little more complicated. Now that you know the scientific method, you can understand why some scientific answers are still undefined. Nearly every experiment takes at least a few tries before getting a concluding result, but some can take up to hundreds. I hope this video has taught you more about the scientific method. Thank you so much for watching.
Created using Powtoon.